enthalpy. Enthalpy is a state function. Used to represent the thermodynamic state of the system. Moreover, this is extensive property. Extensive property. Clear? To understand the concept of enthalpy, let us consider a piston cylinder arrangement. This is cylinder, this is piston, a gas is confined in a piston cylinder arrangement. Subject to the condition, piston is frictionless. Piston is the frictionless. Okay. Now, a new arrangement is provided, a knot is provided here to arrest the movement of piston. This ensures the volume of gas is constant. Next point, pressure inside the gas will be increased. Okay. Now suppose certain amount of energy added to the system as heat. The amount of energy added to the system as heat. The added energy is stored as such internal energy. So changes in internal energy is equal to amount of heat added to the system. Condition is volume is constant. Volume is constant. Volume is constant. V is equal to constant. Hence changes in volume is equal to 0. Needless to worry about the pressure. Pressure will be increased. Pressure of the gas will be increased. Okay. This is the first case. For a constant volume process, the amount of heat added to the system is equal to changes in internal energy of the system. This is the case 1. Case 2. Now the knot is removed. Listen here. There is no knot. The system is free to changes its volume. Now the system is free to changes its volume by expansion. Suppose certain amount of heat added to the system. In this case, volume will be increased, pressure is constant. Certain amount of heat added to the system, upon the addition of heat, the gas gets expanded against the constant external pressure. Pressure is constant. Volume will be increased. In such a case, changes in internal energy will not be equal to amount of heat added to the system. It will be less than amount of heat added to the system. That means if you are adding 10 joules of heat to the system, the changes in internal energy will be 8 joules. What about the remaining 2 joules? This is the question. Remaining 2 joules. That means a part of energy added to the system is utilized to push the surroundings against constant external pressure. To push the surroundings against the constant external pressure. Constant external pressure. That means certain amount of work is done by the system to occupy a new volume. Volume will be increased. Certain amount of work is done by the system to occupy a new volume. Clear? In such a case, amount of heat added to the system can be measured by using a new thermodynamic property, what we call the enthalpy. For a constant pressure process, the amount of heat added to the system can be measured by using a new thermodynamic property, enthalpy. Perhaps Enthalpy is the important property widely used in most of the thermodynamic calculations. Clear? Okay. Mathematically, H is equal to U plus PV. U plus PV. H stands for enthalpy. U stands for internal energy. Internal energy is also a state function. Pressure P, absolute pressure. Okay, this is also a state function. Volume of the system or gas, this is also a state function. So hence, enthalpy is also a state function. Clear? This is the mathematical form of enthalpy. Here, the product of PV represents the amount of work done. Amount of work done. The product of PV used to represent the amount of work done. In most of the textbooks, they are representing enthalpy is the total energy of the system. Total energy of the system. Total energy of the system. Okay. Now I am going to differentiate this equation. H is equal to U plus PV. Upon differentiation, dH is equal to du plus d, the product of P into V. First law of thermodynamics says that the changes in internal energy du is equal to dq minus dw. Now I am going to substitute this one here. So del H is dH is equal to dq minus dw. Upon differentiation, this becomes P into dV plus V into dP. I am already telling that pressure is constant. Pressure is constant in this case, hence this term gets cancelled. Changes in pressure become zero. Clear? This is the work done on the system. This is work done by the system. Both are exactly equal. Hence, these two terms gets cancelled. The remaining thing is dq is equal to dH is equal to dq. It infers that for a mechanically reversible, why I am telling this one, piston is a frictionless. There is no energy loss due to friction. So I am telling for a mechanically reversible process, non-flow process, the amount of heat added to the system is exactly equal to changes in enthalpy. இது எப்படி எழுதணும்னு சொன்னா, the changes in enthalpy, the changes in enthalpy of a mechanically reversible non-flow process, the changes in enthalpy of a mechanically reversible non-flow process at constant pressure. dH is equal to dq. This is the concept of enthalpy. Thank you.